All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up number 96 is on the screen, so by now you should be able to do that one on your own. Let's get started. Got about 5 minutes. And today we're moving on. We're going to get started with logarithms. Yes, so make sure stay focused because it's going to go pretty quick. And your noodle's going to be like, what is going on? What's going on? So stay focused, copy and go. All right, here we go. Number 1, A. You should have gotten 1 over 32. Hands if you got that. Okay. Number 2, you should have gotten 9. Oh, no, not bad. Should have gotten 8. Hands if you got that. Okay, good. 1C, you should have gotten, this was a 4 inside, so this is square root of 8. Hands if you got that. Okay, good. Number 2, 2 to the x minus 4 is the same as 2 to the x over 16. Hands if you got that. Okay, good. Number 3, the half is the same thing as a square root, is that correct? So what is square root of 9? 3. Once again, half of an exponent is the same as a square root, so what is square root of 64? 8. This one we needed to rewrite it, so let me zoom into that one really quick. That one needed to be first rewritten. So that means the exponent is 1 over 3 times 2. This is the same as this. So the base is still 27, which means this is a radical to the index of 3. What stayed outside? The 2. Therefore, what number times itself 3 times, because that's what that says, gives us 27. 3, but we have an exponent outside, which is a squared, so what is 3 squared? 9. So the answer for this one is 9. All right. Next. This is a parent exponential function, your home plate, remember that? There it is. And according to this transformation, it's moving 5 to the right and 3 up, so it's going to be somewhere up here. All right, and last but not least, our trig functions. Here we go. Sine angle B. Like B, yeah, that's what it says here. Now the angle changed, so we are going to focus here now. So, for sine, it's opposite side over hypotenuse. So what is the opposite side of angle B? The opposite side is 4. What is the hypotenuse? 5. And this is 0.8. Cosine angle B. Cosine angle B, it says adjacent side over hypotenuse. So here's the angle B. What side is next to B? The 3, because the 5 is the hypotenuse, right? So this would be 3 over 5. And that gives us 0.6. Last but not least, tangent of angle B. All right, it says opposite side over adjacent. What is the opposite side of B? 4 over what? 3. 4 over 3, which is 1.3. All right, we good? Agenda for today, here we go. Warm-up number 96, logarithmic functions. We're moving on, and your home play pages for tonight, 755, 756, numbers 5 through 15 only. And you can find that in Canvas. When you go to Canvas, to our home page, click on modules, and you're going to have a new module, which is labeled what? Logarithmic functions. You're going to find the home plate in there. So, like I said, we're moving on. You need a Cornell note. You do need a Ferrer model. So, here we go. Oh, also, last night's home plate, turn that in, please, on canvas. So last night's home plate was 4 transformations of this parent function. So the home plate for tonight, once again, SAM 55, SAM 56, numbers 5 to 15. And as I mentioned, you can find those on canvas. All right. I'll give you some time to turn that home plate in. Get a Cornell note ready, once again, with a Ferrer model. There's the objective, and we'll get started in a little bit. Copy that and go. Our objective for today, I can define and evaluate logarithmic functions. I can define and evaluate logarithmic functions. As I mentioned, we're moving on from where we were before. So what are logarithmic functions in your Ferrer model? Logarithmic functions, also known as logs, are the inverse of an exponential function. Let me repeat that again. Logs are the inverse of an exponential function. Logs are the inverse of an exponential function. That's why we use the same base where it says b, and it has to be greater than 0, but it cannot equal 1. Now, let me show you how they are written right there in the definition. They can be written as follows. F inverse of x equals log b of x, or x equals log b of a. Those are logarithmic functions. Bless you. Other examples of logarithmic functions, here it is. F inverse of x equals log base 5 of x. And 3 equals log base 4 of 64. Now, according to the definition, it says it's the inverse of an exponential function, which means it's still a function. That's why it says logarithmic function. Do we have an equal sign? Yes. Does it look like a function? Yes. But what is the one thing that really jumps out at you in these functions? What do you guys notice? Yeah, the word. What's the word? Log, exactly. If it says log, then guess what? It's a logarithmic function. So obviously, if it doesn't say log, it's not. Non-examples. Copy these. As you're copying these down, ask yourself, why are those not logarithmic functions? Look at them. All right, tell your neighbor, why are those not logarithmic functions? Obvious, right? Because they don't say log. My goodness. Therefore, one thing, hashtag, that it has to be true, it has to be a function. Hashtag function. What else? Hashtag the base is what? B. Yeah, same as we started before. And now, hashtag, we're going to solve for exponent. Solve for exponent. So basically, logs came about, guys, because they figured, okay, we know how to solve for variables, we know how to solve functions, different types of functions, but they started encountering some issues with exponents. They were saying, how can we talk about exponents without saying exponents? So they said, let's call them logarithmic functions. That's what they called them. All right, so now that we know what they look like, let me elaborate as to logarithms are. Here it goes. What are logarithms? Logarithms are basically a question. Look up to the screen. What question, Mr. Q? Here's a question. This is probably the best as I can do, Mr. Q, to explain logs to you. Here we go. A logarithmic function is a question, and it reads as follows. To what exponent does a base need to be raised to in order to get a given number? Let me translate that to a symbol. It reads like this. Let me read it again, but now using the symbol. To what exponent, x, does a base, b, need to be raised, that's what the log means, in order to get the given number a? It's a question. Copy that, and then copy this table. We're going to first practice rewriting these logs, because in order to solve log functions, they cannot be written in log form. They have to be written in their inverse, which is an exponential. Copy that, set up that table. I'll give you a couple minutes. Go. Once again, the first log, you're going to write it here on the column for logarithmic functions, and then we're going to rewrite those as exponentials. Okay? So, I'm starting with these three colors just so that you can see where the placement of each component goes. But afterwards, with practice, it's all going to be one color, but just so that initial so you guys can see it. Alright, here we go. Writing utensils down, look up to the screen. You'll finish copying in a little bit. I know it's taking you a little bit more time to set up the table, but here it goes for the sake of time. All ready? All right, here we go. Stay focused, please. Oh, from this point, your noodle's going to start stretching. Here it goes. These are logarithmic functions. On this side, we're going to write their inverse. What is their inverse? Exponential functions. Now, why do I need for us to write it like that? Because we need it in an exponential form in order for us to solve it. So check this out. This is how we write it. The exponential form of this one is this. The question was, to what exponent does the base need to be raised? That means the letter B is the base. To what exponent does it need to be raised in order to get a given number what? A. And notice now I did not use the log anymore because now it's an exponential function. Copy that, please. And some of you are asking, so what happens to the word log, Mr. Q? The word log goes away because we rewrote it like this in order to understand the question. What was the question? To what exponent does the base need to be raised in order to get this number? That's what log stands for. It's basically a question. Okay? All right. So now that we did the basic, let's add some numbers to this. Here we go. Copy this one underneath that. X equals log 2 to get 64. X equals log 2 to get 64. So I'll give you a head start and see if you can rewrite that one as an exponential function. X equals log 2 to get 64. Alright. So let's see. What do we start with? In order to get an exponential, we need to start with a base. What is our base, everyone? 2. The exponent is still x. And what number do we need to get? 64. That is correct. Hands if you got that. Okay, let's do another one. Here we go. Copy this. X equals log 5 to get 125. Just rewrite it. All right, show your neighbor, see what they got. See if they have something similar to you. Alright, so we should have gone base 5, exponent of x, equal to get the number 125. Hands if you got that? Okay, let's do some more practice. So without a table, now write example 1 and copy these instructions because, oh, there it is. Because this is exactly how the home is going to read. And they're going to say, rewrite the log as an exponential. And notice here I already took away the colors. Hopefully you should be able to rewrite that one without the colors, yes? And it reads, number 1, rewrite the log as an exponential, and they give us x equals log 4 to get 16. Just rewrite that underneath. All right, Zachary, go. 4x 4 to the x equals 16. Hands, have you got that? Okay, let's do another one. Here we go. Example 1Q, x equals log 3, 81. All right, show your neighbor what you got. Make sure they got the same thing. All right, Diego, what'd you get? 3 to the x equals 81. Hands, have you got that? Okay, let's do one more. Example 1 super cube. X equals log 2 to get 1/4. All right, Fatima, what'd you get? 2 to the x equals 1/4. Hands, have you got that? All right, from 1 to 5, I'll come to value with this. Now, it is said that the brain, how the brain works, is that you need to know stuff one way and backwards, right? Frontwards and backwards. All right, so we did from log to exponential, so copy this. Now we're going to go from exponential to log. Copy that. It says, example 2, rewrite the exponential function as a log. They give us 2 to the x equals 32. 2 to the x equals 32. See if you can rewrite that one as a log now. All right. All right, help me with this one. Mel, go. X equals log 2 to get 32. Hands, if you got that. That is correct. Let's do another one. Example 2Q. 4 to the x equals 64. 4 to the x equals 64. All right, show your neighbor, see if they have the same thing as you. They should be done by now. 4 to the x equals 64 as a log. All right, Sebastian, go. Hands, have you got that? That is correct. One last one. Here we go. Example 2 super Q. 2 to the x equals 1/8. 2 to the x equals 1/8. All right. Jehu, go. Log 2 to get 1/8. Hands, have you got that? All right. From 1 to 5, how comfortable are you going backwards and forwards? We got this? Yes? 5, 5, 5, 5. Okay. Alright, so now that we're done with the basic, notice that we haven't solved anything, we just rewrote it, right? Okay, now we're going to solve them. Oh yes, here we go, copy this. Example 3. Solve for x. Example 3, instructions solve for x, and they give us x equals log 2 to get 1/8. X equals log 2 to get 1/8. Once again, now we are solving. Okay. Here we go. Step 1. I'm going to write the step 1 over here. Rewrite as exponential. Do you know how to do that for this, guys? Yes. Let's see. Rewrite it as an exponential, please. All right. Daniel, go. 2 to the x equals 1/8. Hands, have you got that? Okay, so that's step 1. All right, here goes the next portion. I need you to stay focused, writing your utensils down, look up to the screen. For this second step, we need to make this side look like this side. What does that mean, Mr. Q? That means that if this one is base 2, that means this has to be what? Base 2. So how can I write this 8 using base 2? Think about it. 2 to the what gives me 8? That's the question, right? So, do you have it in there? So, this becomes 2 to the third, and that is equal to 2 to the x. Hold on before you do anything else. They're almost about the same. But notice this is in the denominator, and this one, if you think about it, it's in the what? Numerator. So how can I take this one and move it to the numerator? Yeah, the reciprocal, and that is going to change the exponent into a what? Negative. 2 to the negative 3 equals 2 to the x. And my last step, I look at the exponents and make an equation. X equals negative 3. Copy that, please. Okay. So recap. What is the first thing we needed to do to this? We need to rewrite it as a what? Exponential function, or else we won't be able to solve it. Question. What would we call step 2? What would you say for step 2? Do the reciprocal, but before we did the reciprocal, what did we need it to do? Yes, same base. Both sides need to have the same base. And at the end, solve for x, or for the variable. 3 basic steps. Rewrite, make sure they have the same base, and then solve for x once you have the exponents matched up. Alright, let's do another one. See if you can go ahead of me and see how you do by yourself. Here we go. Example 3 cubed. We got solve for x. X equals log 3, 1 over 81. X equals log 3, 1 over 81. All right. Exponential form. Xavier, go. 3 to the x equals 1 over 81. Hands if you got it to right there. Yes. Step 2, they need to be the same base. Now, for those of you that are struggling, look up to the screen. Mr. Q, how do you guys get that same base? Well, if this one could be written using base 3, then that means in your brain you need to do this. 81 divided by 3. How many times does 3 fit into 8? Twice. 6, subtract 2, bring down the 1, into that 7. That means the 81 has factors of 3 and 27. Can I factor the 27 again? Yeah. How many times does the 3 fit into 27? 9. Yeah, 3 times 9 is 27. Next, how many times does 3 fit into the 9? 3 times. So how many 3's do we see here? 4. So this can be written as 3 to the 4th equals 3 to the x. Hands if you got it to right there. Okay? Now, can we leave it in the denominator? No. We do the reciprocal. That means we have 3 to the negative 4 equals 3 to the x. And then we look at the exponents. That means x equals negative 4. Hands if you got that. Okay? You're like, okay, I get it now. Yeah, some of you just needed to figure out the how do we get the same base for that number. So make sure you start with a division, write it as factors, and then continue from there. Let's do another one. Example 3 supercube. X equals log 4 to get 64. X equals log 4 to get 64. And hopefully you can do this one all the way by yourself. Finish it off, please. I'll give you some time. Copy and go. All right, check with the neighbor, see what they got. Hopefully they got the same thing as you. All right, I think Jehu's got this. Let's see. Go, Jehu. What's the first thing I do? Therefore, equals 64. Thank you. Pass someone. Pablo. Next. What do I write? Same base. So what do I write?
4 to x equals 1 over 4 to the third. 1 over 4 to the third.
But this isn't a fraction. So it's just 4 to the third. Is that correct? All right. Therefore, x equals 3. Hands, have you got that? Okay. From 1 to 5, how can borrow you with these? 5, 5, 5. Okay. So, I think we're good with these, yeah? So your home plate, the first 2 parts, you're good? You all ready for the last part? Let's crank it up a little bit, yeah? You're like, I knew it. Here we go. Copy this. Example number 4. Evaluate the logarithmic function, and they give us the function f of x equals log 7x. 4, we're going to evaluate for f of 49, f of 1 over 343, and f of 7, square root of 7. Copy that. All right, let's see what it says. It says, evaluate the logarithmic function, which means this one. How do we evaluate? We substitute these values in here, and then we get to work. How do we do that, Mr. Gear? Here it goes. Writing utensils down, look up to the screen. I'll do the first couple of steps, and then we're going to do the rest together. Ready? Here it goes. First things first, I need to use this function, and I'm going to evaluate it according to this first value. What's the first value that they give us? 49. That means I need to write this, but without the x's. Don't we do that usually with functions? Yes. So this becomes f of log 7, parentheses for the x. Before you copy, just focus. Here it goes. So what value am I going to substitute in there? 49, 49. In order to get started, I need to rewrite this. I cannot have a function notation on this side. What was the function notation before it became function notation back in the year? Tell you here, what was it before it became function notation? I think Leo's got it. Leo, go. What was it before it was a function notation? What? Sebastian? Y is correct. We changed that to Y. Therefore, log 7, 49. Copy this really quick. So what is the first thing we did? We opened parentheses for the x's, substituted the value of 49, and rewrote it as the original form, which was y. But now to get the number 49. Can we solve that? Yeah. Sebastian, pass someone. Justin, what would be our next step? Okay, tell me what to write. To the y equals. Yes. Pass someone. Leo. Next. 7 to the y equals. To the 2. Yes, that is correct. And pass it to Mr. Q. All right. So look at the exponent. So y equals 2. Piece of cake? Yes. So what is the only thing that we added on this one? We needed to substitute the value first and change it to y form. All right. So I'm going to give you a head start. See if you can do this next one now. Now the value that we need to substitute is 1 over 343. I'll give you a head start. And I'll help you get started. F of equals log 7 parentheses. All right, Leo, pass someone. Vince, go. 1 over 343. Thank you. Pass someone. Yes. And have you got up to right there? Yes. Pass someone. Justin. 7y equals 1 over 7 to the 3rd. Let's go. How do you get that? Well, didn't I show you guys that you can take this 343 and divide it by the same base, which is 7? 7 times what gives us 34? That's 20 times 4, that's 28. Subtract that 6, bring down the 3. 7 times what gives us 63? 9. So my two factors for 343 are what? 7 and 49. Can we break down the 49 more? Yes. 7 times what? 7 gives us 49. So how many 7s? 1, 2, 3. That's how he got 7 to the third. All right. Pass someone. Erica. 7 to the y equals 7 to the negative 3. Yes, because we did the reciprocal. Therefore, focus on the exponent. So y equals negative 3. Ooh, let's go. Yes? Pretty good, yeah? All right. Let's go with the last one. Let's do the last one together. The last one's going to be a bit challenging, but it's doable. Here you go. And again, we got f of equals log 7 parentheses. And now we're going to substitute 7 square root 7. Oh. 7 square root 7. All right. Erica, pass them on. Fatima, go.
It would be y equals log 7 parentheses.
Okay. Once we rewrite it, we don't need the parentheses anymore. We can leave it without the parentheses. Okay, so it's y equals. All right. Pass on one, Fatima. Mel? All right, so far so good. Now, there's two ways of approaching this one. I'm going to go, check this out. Let me zoom in. Let's see if your noodle catches it. Doesn't this seem familiar? Yeah, very good. What was this one before it was outside of the square root? 49, yes? Square root of 49. And then I bring down square root of 7. Okay. However, we can rewrite this as 1. So square root of 7 times, hold on. Instead of writing 49, can I write 49 on base 7? 7 to the what? Square. So now we have 7 to the first and 7 to the square, which means we have 7y equals square root of 7 to the third. But we still have a dilemma. We have a square root. What is a square root in exponential form? Tell your neighbor. Square root in exponential form. Let's see, I think Sebastian's got it. A square root is also known as what? What kind of exponent? Very close. He said 2. But Kevin says what? To the power of what? Very close. That's what Sebastian said. Jessica? 1/2. That is correct. On the warm-ups, we've been using this. Yes? Yes, Mr. Q. All right, good. So that means that this is 7 to the y equals 7 to the 3/2. Therefore, what is y? Y equals 3/2. Ooh, let's go. Let's go. Well, not yet. We still have time. Bye. All right, let me go back to recap the process to make sure we got it. So when they give us a function, what is the first thing we do? We need to substitute value, whatever that value it is that they give us. And then we need to rewrite it in its original form, which is in y form. From there we know what to do, writing an exponential, same base, and finding the variable, the missing variable. Same thing here, same thing here. The only thing with radicals, just remember whenever you have a square root, it's what kind of exponent? 1/2. Now let me show you a shortcut. You guys want to know the shortcut? Look at this one right here. Let's say this step, instead of doing all this, isn't this 7 times square root of 7? Or 7 to the first times 7 to the 1/2. So what is 1 and 1/2? Very good. 7 and 1.5, or if you want to change that in fraction form, 7 and 3/2. Anyway, we got it? From 1 to 5, how comfortable are you with these? You're like, I was good till the last one. Yeah, right? We didn't need practice? All right, good. Good, you mentioned it. Let's do another one of the last ones. Copy this one. F of, oh wait, we only have 1 minute. I guess we'll stop right there. So you get plenty of practice tonight. Once again, you can find the home play. The home play is pages 755, 756, numbers 15 through 5 through 15. Make sure you go to Canvas. It's in the new module in there. Enjoy your home play. And I'll stop the video right now. Bye.